Okay, now that we've discussed what a permutation is, we also have what's called a combination. So we're going to find probabilities using combinations today. And combinations is a selection of objects in which order is not important or order does not matter. So the difference would be like a permutation. If I were going to select 3 students from the class, and the first person I select is the president, the second person I select is the vice president, the third person is the secretary. Their order matters. That's a permutation. But if I were going to select just 3 students to be on the student council, they're going to represent this class, it wouldn't matter what order I selected the students. They're just on the committee or on the council. So any 3 students, it wouldn't matter who was first, second, or third. It's just those 3 students. That's a combination, okay, where order doesn't matter. Okay, example 1, it says count the combination of 2 letters from the list. So when I write down my combinations and I say, well, AB is a combination, AC is a combination, or AD is a combination. Okay, then I could have BC, okay, and I could do BD. I don't have those yet. And then I could do CD, okay, but I can't do like BA. BA does not work because I already have those same 2 letters, okay? So I can't do, that's not a different combination. It's the same 2 letters, just in a different order. So order does not matter, so we just have, in this case, we have 6 different combinations for those letters. Okay, now a little bit different formula, but we have a key on our calculator that's going to do this factorial work for us. But combination is NCR, so it looks just like permutations. N is still the number of objects that we have to choose from, and R is still the number of objects that we're choosing. It's just now a combination where order doesn't matter. And here's the factorial. It's N factorial divided by N minus R factorial. That much of it, that was the permutation formula. But then you have to divide by an additional R factorial. Okay, so when we evaluate these on our calculators, you have a key that says NCR. It's above the 2 on my calculator. So again, I'm going to type in that first number 8. And then I'm going to hit Shift, hit the combination key, and then I'm going to type in the second number, the 5, and hit equals. This comes out to be 56. Okay? If I do 11 combination 4, 11 combination 4, I get 330. Okay, so make sure you can find that key on your calculator. Now the biggest challenge on this worksheet is going to be determining, because there's going to be permutations and combinations on the same worksheet, and you have to determine by the context, is it a permutation, does order matter, or is it a combination where order doesn't matter? Okay, so example 2, it says tell whether the question can be answered using combinations or permutations, then answer the question. So 3 students from a class of 100 will be selected to be on the student handbook committee. How many committees of 3 are possible? So does it matter which students selected first or second or third, or are they just on the committee? Okay, that's a combination. Okay, that's going to be, there's 100 kids in the class and they're going to choose 3. Doesn't matter what order they're chosen, they're just members of the committee. So I do 100, shift, combination 3. Okay, I get 161,700 possibilities. Okay, part B, it says 3 students from a class of 200 will be selected to be president, vice president, and secretary for the class next year. How many different ways can these roles be filled? Now this is different. So if you were selected to be president, that's one order that can be established, but the same student could be selected as the secretary. That's a different order. So this order matters. This is a permutation. Okay, there's 200 kids to select, and they're going to select 3 of them. So I would do 200, go back to my permutation key. Okay, that is 7,880,400. Okay. You order a sandwich at a restaurant, and you choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Now, does it matter if you ordered French fries first and then a salad, or you ordered the salad first and then the French fries, or are you just going to get your food and have both of those there? Okay, order doesn't matter. Okay, so it's a combination. There's 8 to choose from, and I'm choosing 2 of them.
So I'm going to do 8, combination 2.
And I've got 28 different combinations that I could have with my meal.
Okay, lastly, it says a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. What is the probability? Okay, now we're talking about probability here. But what is the probability that your photo and your friend's photo are the 2 placed at the top of the page? So how many different combinations would there be if there's 14 photos and you want you and your friend? Okay, now remember, it doesn't matter which one's on the left of the page and which one's on the right of the page. Just you and your friend are somewhere on the page there. So 14, combination 2. Okay, that means there's 91 different combinations that could be created from those 14 photos. And it says, what's the probability that your photo and your friend's photo? So I'm going to say the probability is 1 out of 91. There's one combination where it's me and my friend, and there's 91 different combinations. So I'm going to say 1 out of 91. That's my probability. Okay? Should give that worksheet a shot.